Financial modeling and product economics. The first section we're going to focus on is the AI cost structure and why this isn't traditional software as a service. All right, so we've spent the last two sections talking about how to build iteratively and how to launch based on who your customer is. Now we need to talk about something a lot of founders and product people avoid for as long as possible: money. And I get it. Most of you got into building products because you love the craft and you genuinely want to deliver something that's going to add value to a user's life. Not because you dream about spreadsheets. But here's the thing. If you don't understand how the money flows in your AI product, you may end up building something beautiful, but that unfortunately goes under. Let's make sure that doesn't happen. I want to start with an analogy that I think makes this core idea really clear. Let's think about Coca-Cola. Yes, Coca-Cola. Coca-Cola is an incredible business, but every single can they sell costs them something to produce. Syrup, water, aluminium, bottling, distribution. If they sell twice as many cans next quarter, their costs go up. Yes, they get volume discounts. Yes, they have massive economies of scale, but their costs are real and they never go to zero. Every unit has a real cost. Now let's think about a traditional SaaS company, something like a project management software or a CRM. You build the product once, and then every additional customer who logs in costs you almost nothing. Maybe a bit of a cost in server hosting, but it's essentially negligible. That's why software companies have had historically high margins, often 75 to 80% gross margin. The cost of delivering the product to one more user is closer to zero. Here's the thing, AI products are more analogous to Coca-Cola than the average SaaS company. Every generation, every inference has a real tangible cost, like a can that needs to be filled, and that changes everything. So let me walk you through the different layers of cost that you need to understand if you are building an AI product. Let's start with a term you're going to hear a lot today. COGS is essentially the cost of goods sold. Don't let the jargon scare you, it's a simple idea. COGS is the direct cost of delivering your product to a customer. For Coca-Cola, it's the syrup and the can. For traditional software, it's mostly the cost of hosting, servers, and the cloud bill. And it's usually tiny, which is why SaaS has been an incredible business model for decades. But for AI, COGS is a real thing that you need to understand. So let me break down each component of AI COGS. Component 1, inference and compute costs. This is a very big one. Every time a user sends a request to your AI product, every time they ask a question, generate an email, get a code suggestion, your product is running a large language model or some AI model behind the scenes to produce that response. That computation is called inference, and it runs on expensive machines called GPUs. These are specialized chips that AI models need. A single high-end GPU like an NVIDIA H100 can cost between $25,000 and $40,000 to buy outright. If you're renting them in the cloud, you are paying anywhere between $2 to $7 per hour per chip, depending on the provider and whether you've negotiated discounts. And in some cases, your model might need multiple GPUs running simultaneously to handle a single request. Like traditional SaaS, where the server just retrieves some data from a database and sends it back, AI inference involves billions of mathematical calculation for every single response. That is why the cost per request or query is orders of magnitude higher than anything traditional software companies have ever had to deal with. And critically, this cost scales with usage. More users means more requests, which means more queries, which means more money out of the door. Unfortunately, there is no escaping this relationship. Let me make this concrete with a quick calculation. Say you have a product that handles 100 user requests or queries per day, and each query takes about 2 seconds of GPU time on a mid-range system that costs $4 an hour. That's essentially 2/10 of a cent per query. Sounds tiny, right? But let's multiply this out across 100,000 queries per day. That is $200 per day. That's roughly $6,000 per month just in inference alone. Now imagine you grow to 1 million queries or 1 million requests per day. That's $60,000 in queries alone. And that's before you've optimized anything. That's before you've added other layers which we're about to discuss. In AI products, unfortunately, scale amplifies everything. The second component I'd like to focus on is API costs. Many of you will probably build your AI products on top of existing foundation models rather than training your own. That means you are calling an API from a provider like Anthropic, OpenAI, or Google. And guess what? They charge per token. What is a token? A token is roughly 3/4 of a word. So 1,000-word response is essentially 1,300 tokens. Let me give you some real numbers. Anthropic's Claude, one of the leading AI providers, has a tiered pricing structure. The fastest and cheapest model costs $1 per million input tokens and $5 per million output tokens. Their mid-tier model, Sonnet, runs at $3 input and $15 output per million tokens. And their most capable model, Opus, costs $5 input and $25 output. These numbers could sound small. Oh, it's just a few dollars per million. But think about what happens at scale. If your product is handling 10 million queries per day and each query involves few thousand tokens, you are looking at thousands of dollars in API costs daily, just for the model cost alone, before you've even paid for anything else. And there's an important nuance. Output tokens are much more expensive than input tokens. They typically cost 3 to 5 times more. That's because generating a response requires more computation than reading a response. So the length and complexity of your model's response directly impacts your costs. If your product tends to generate long, detailed answers, your bill goes up accordingly. Now let's look at component 3. This is specific for some of you, not all of you, who are training or fine-tuning your own model. Let's say you need to fine-tune an existing model on your specific data. What is fine-tuning? Fine-tuning is when you take a general purpose LLM model and you train it further on your own domain-specific data so it performs better for your specific use case. But there's a real cost. You need GPU time to run training runs, and you need engineers who know how to do it. And unfortunately, you may need to redo it every time the base LLM model changes or updates. It is not a one-time expense, it's an ongoing part of your cost infrastructure. And if the base model provider like OpenAI or Anthropic releases a new version that's significantly cheaper, your customer may expect you to upgrade, which may mean refining your models from scratch. Another component is data costs. This one is easy to overlook but can be very substantial. Your AI product requires data to be useful. It may require training data, evaluation data, retrieval data, user data. Acquiring and maintaining high quality data sets costs real money. If you're building a product that uses RAG, where the model pulls knowledge from a database to answer questions, you need to build, store, and continually update that knowledge base. That's storage costs, embedding costs, indexing costs. And the data landscape is getting more interesting. Recent report shows that niche data labeling services are now paying specialized humans up to $500,000 a year to create high quality domain specific data for AI labs. 100 of those labelers could cost $50 million annually. And that's just the current price of getting high quality data in specialized domains like medicine, law, or finance. Now, most of you won't be operating at that scale or maybe even paying that amount, but the underlying point applies. Good data is expensive, and it's a cost that never fully goes away. Now, let's talk about another component of cost: infrastructure and orchestration. Before the raw model costs, you need the infrastructure to run everything. That includes your cloud hosting for the application itself, your databases, your vector stores for retrieval, your caching layers, your monitoring, your logging systems. You also need orchestration, the software that manages how request flows through your system. It also manages how different models are called, how results are combined, and then returned to the user. If you are building an agentic AI platform where the AI takes multiple steps to complete a task, the orchestration layer becomes even more important and more expensive because a single user request might trigger dozens of model calls behind the scenes. Let me give you a sense of what this adds up to. A typical AI application might need a vector database like Pinecone or Weavect, which runs anywhere from a few hundred to several hundreds of thousands per month, depending on scale. You might need a caching layer to avoid recomputing identical queries. You need it typically to save money, but itself costs money to run. You may need observability tools to monitor the latency, error rates, and token usage so you can spot cost spikes before they become crisis. You might need a content moderator pipeline to filter inappropriate inputs and outputs. None of these actually look like huge individual costs, but they compound very quickly. An AI product team might look at their model API bill and think that's the whole picture. But in practice, infrastructure and orchestration can add up to 50% on top of your raw model costs. Now let's talk about another aspect that I mentioned earlier in the course: human in the loop costs. Many AI products require some degree of human involvement. This might be quality assurance, where humans review a sample of the model's output to catch errors. It might involve safety reviews where sensitive outputs are flagged for human evaluation. It might be reinforcement learning from human feedback, which is a process of having humans rate the model responses to improve its behavior over time. These human costs don't necessarily show up in your API bill, but they are real and they can be quite significant, especially in regulated industries like healthcare or financial services where accuracy matters enormously. If your product is making recommendations that affect people's health, their finances, or their legal standing, you will most certainly need human oversight as a safety net. And that oversight needs to be staffed and, importantly, paid for. So, when you add all of this up, inference compute, API costs, maybe training and fine-tuning depending on your company, data acquisition, infrastructure, human review, you get a cost structure that looks fundamentally different from a traditional SaaS company. In traditional SaaS, growth made the business more efficient, not less. You'd be able to add 10,000 new users and your hosting costs might go up, but your revenue went up a lot more. In AI, growth can make the business less efficient if you're not careful. Every new user who loves your product and uses it heavily is generating a real, tangible cost. A widely cited State of AI reports put it simply, COGS is the new CAC. CAC is defined as the customer acquisition cost, essentially how much you are spending to get a new customer. In the old SaaS world, the big question was, can you acquire customers efficiently? In the AI world, the big question shifted to, can you serve those customers efficiently? And that's a fundamental change in how you need to think about your AI product or AI business. But hey, it's not all bad news though. There is some good news. Research shows that these inference costs have been falling dramatically. They have been roughly dropping 50 to 200 times per year since 2024, depending on the task and the benchmark. It's great news, but here's the catch. The most capable models that are delivering the highest performance are often bigger and more expensive to run. And the newer reasoning models, the ones that think through a problem step by step, can consume 50 times more token from a single query. So yes, you are getting cheaper per token, but you are also using exponentially more tokens per request or per task. This is the landscape that you are building in. 6 layers of costs, all of them real, and most of them will apply to most AI products. And importantly, the costs scale with usage. So here's the action item from this segment. It is important for you to sit down and map out your cost stack. Write down each of those components and estimate what they would cost you based on 100 users, 1,000 users, and 10,000 users. Look at which costs scale linearly. Which ones may grow faster than your revenue? Where are you most exposed? You don't need the exact numbers yet, but rough estimates are fine. You are able to sometimes find these numbers by running through an actual query and running experiments across different providers. But the key takeaway here is that you need to know where the money goes before you can make smart decisions about margins and pricing, which is exactly what we're going to cover next in the next section. Thank you.